which was an anonymous spreadsheet. If you want to see, we have some people who are behind already. That's normal. So we're recording. Let's go to chemical organization. We're all made out of chemicals. Obviously, every living thing is made out of basic atoms and molecules. So that's why we're going to talk about the chemical level of organization. So we are definitely recording. So everybody's made out of neutrons, protons, and electrons. Nobody's ever seen a neutron. They've seen in a cloud chamber, if you know what a cloud chamber is. So you should know about protons, neutrons, and electrons and their charges. You should know that the protons and neutrons are in the nucleus. The electrons are outside in what's called the electron shell. You should know that atomic number is the number of protons. Protons plus neutrons equals atomic mass. If you have a substance that has varying amounts of neutrons, you can have carbon 12, carbon 13, carbon 14. Mostly the mass of the neutrons and protons adds up to the atomic mass or atomic weight. Electrons surround the nucleus. They're organized in layers of shells, and the outside shells determine the characteristics of various atoms. So you've probably seen this diagram since you were a little kid. Nucleus, protons, and neutrons. Neutrons have no charge. Protons are positive. These are the various shells. This shell or layer and this outer layer. So we have a carbon atom with 6 protons, 6 neutrons, and 6 electrons. So be familiar with shells, the charges of neutrons, electrons, and protons. All matter is composed of atoms. So just think how amazing it is that you put a bunch of atoms together that make molecules, that make cells, that make tissues, that make organs, that make organ systems, and we have life. Unbelievable. Okay, chemical bonds. H2O, water. Hydrogen is connected by a covalent bond to oxygen. Pure hydrogen is a gas. Pure oxygen is a gas. If they are connected by a chemical bond, it's water. Ionic bonds are when electrons are lost or gained. Cations have a positive charge. Anions have a negative charge. So if you take table salt, it's made up of sodium ions with a positive charge and negative ions, chloride, with a negative charge. An ionic bond is the attraction of a positive ion to a negative ion. Ionic bonding happens when sodium, for instance, loses an electron to chloride. Notice the chlorine atom, when it gains an electron, is chloride. Sodium becomes positive. Chloride becomes negative. You have an electrostatic attraction that makes salt. This is the salt crystal. If you have sodium and chloride arranged in a regular formation in this cube, that's salt. Make sure you know that the symbols for sodium and the name, make sure you know the common ions that are found in the body, all organisms. COVID has these ions. Frogs have it. Grasshoppers have it. Goats have. We all share these common ions, positive or negative. If electrons are shared, such as in the water molecule, that's a covalent bond. If a single pair is shared, that's a single covalent bond. If you can share two electrons, two shared electrons, that's a double covalent bond. So hydrogen gas, oxygen gas, carbon dioxide gas. These are all covalent bonds where electrons are shared between two atoms. If there's equal sharing, it's a nonpolar covalent bond. If there's non-equal sharing, there's a polar covalent bond. Water's a polar molecule. CO2 is neutral. Even though the bonds are polar, the molecule is nonpolar. The fact that molecules have polarity, meaning they have unequal distribution of electrons, that's the basis for life. That different molecules have different characteristics. Another type of bond is called hydrogen bonds. So between water molecules, hydrogen bonds are familiar and are the reason for water having a very high boiling point, a low freezing point. That water can flow up the vessels of plants from root to leaf. And of course, we have a potential spam that will knock out. Okay, so here are hydrogen bonds between a slightly positive hydrogen and a slightly negative oxygen. Hydrogen bonds are very, very, very important. Your hemoglobin works and carries oxygen because of hydrogen bonds. The function of proteins and various chemicals, various molecules, their characteristics are due in large part to the formation of hydrogen bonds and to the presence of other charge within the molecule. So you'll figure out what these, make sure you figure out what all of these terms mean, compounds, elements, and so on. Any type of processing that we do of the chemicals in our body and the chemicals we consume and the chemicals that we release is metabolism. Work is the ability to move stuff around. We use energy to do that. Potential energy is stored. Kinetic is the energy of movement. Once potential energy is converted from potential to kinetic. I'm not going to ask any questions about this. You should just know this. Know about decomposition reactions, where a compound is split into two atoms. Hydrolysis is a reaction with water. Catabolism is all the reactions in the body. If you put two atoms together to make a double joined molecule, that's a synthesis reaction. New bonds are formed. We will talk about dehydration synthesis and anabolism, which is all of the synthesis reactions in the body. We won't ask about exchange reactions. We will talk about reversible reactions. It's very important for release of CO2, and the function of CO2 in the body depends upon a reversible reaction. Okay, A lot of energy is lost through heat. We use that to keep us warm. Chemical reactions have to be brought to a level where they're able to convert from one atom to a compound or from a compound to atoms. That energy is called the activation energy. We have catalysts in our body that promote reactions but are not used up. Enzymes are cellular catalysts in our body, and of every living organism on the face of the earth, enzymes are used to carry out reactions. COVID uses enzymes. We use enzymes. Proteins are enzymes, and they cause reactions to occur in living organisms. Activation energy, recombinants or reactants have to be brought to a particular level so that the reaction is completed. What enzymes do is they lower the activation energy. So read through these slides, make sure you know what the words mean. We don't need that. We're not going to worry about that. Y'all know that already. You should know that. You should know what these gases are and the properties of water. So let's stop there, stop recording, and make one